All right, so we're back with another Leetcode easy problem. This problem's called merge two sorted lists, and it's number 21. Let's dive into it. All right, so you're given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists in a one sorted list. I think this should be into one sorted list. The list should be made by splicing together the nodes of the first two lists. So it doesn't want us to copy these to an array, for example, and make a new linked list. It wants us to use the existing nodes of a linked list. Return the head of the merged linked lists. Here's the example. We have a linked list of 1, 2, 4. So 1, 2, 4. And then this would be null, but it doesn't matter. And 1, 3, 4. And what we want to do is we want to go from comparing these, we want to see whichever one's less. In this case, it doesn't matter, so we can take either one. So let's take the first one, skip to the second. So now we have our new list, so it's 1. And then is 1 greater than 1? It's not, so we take it. And then is 2 less than 1? No, so we take 1 from the second list, and we go to the next. So now we have 1 again. And then we compare 2 and 3. 2 is less. Then we can pair 4 and 3. 3 is less. Compare 4 and 4, and they're the same, so we just take one and then take the other. This is what it wants us to do. Return 1, 1, 2, 3, 4, 4. All right, so a couple questions we have is, first off, what's a linked list? If you're not sure what a linked list is, it provides a definition up here for us. It is basically a data structure that provides a value and a next property. So value will store the value. In this case, it would be 1, 2, 4, 1, 3, or 4. That's our value. And the next points to the next one in the list. So for example, if we had a node equals new list node, and our value was 1, and then we had node 2 equals new list node, and our value is 2, if we were to print node1.value, we would get 1. And if we print node2.value, we'd get 2. Now how do we link them together? Well, we could do node1.next equals node2. If we do this, now we can do node1.next.value. That would be 2. And we could also do node2.value. It's still the same thing. That also equals 2. So now they're linked together because we had this linking step. What's a linked list good for? Well, it's really fast with inserting and deleting. So insertion and delete operations are very fast. What's it not so great at? Well, search. You have to go through each element in the linked list to find the one that you are looking for. Before we go into the solution, actually I wanted to talk about how we can iterate through a linked list. So how can we see each element in a linked list? What we can do is we can set a current variable. So this one will be node 1 because that's our head, that's the starting variable of our linked list. And then we could do a while loop, while current console.log current.value. And that would print, in this case, it would print 1. And then the only thing we need to do is update current equals current.next. And so once it hits current the second time, current.value is going to equal 2 because we linked them together in this step here. The next time current equals current.next, this is actually set to null, and so this stops running. And so we've visited both items on our linked list. Now this is important because we're going to use this in our algorithm. So let's see how this will help us solve our algorithm question above. As we start to solve it, what we want to do first is we want to just check, is our list 1 or list 2 even there? Because they can actually be empty. If we look here, there can be as little as 0 nodes in our linked list and as many as 50. So we want to handle the 0 case. So what we can do first is we can check, if not list 1 and not list 2, return list1, which should just be null. If not list1, well, we can return list2 because we know we've checked for both of them and they're not both absent, so we'll just check for one. And then we can do the same thing here. If not list2, return list1. And this will cover those cases where one of them is 0. Then we just return the other. Now here we want to set aside a head variable because this variable is going to be what we return at the end of our algorithm. So we'll set this aside, and we need to decide what the first value is going to be. So we can check that by doing list1.value if list1 value is less than list2.value. If it is, we will do head equals list1. And then to make our while loop easier later, we'll set list1 equal to list1.next because we've already used, whoops, not list2, list1.next. Because we've already used the first one, we'll just set it to the next one. But if list1.value is not less than list2, we can actually set head equal to list2. So whatever the lowest value is, that's what we'll set the head first. If they're duplicates, like in our example over here, where they're both 1, then we'll just default to the second one, which is fine. Now we're going to do the same thing where list2 equals list2.next, because we've already used that. We've already used that node. We don't want to duplicate it. And now what we can do is we can go into our while loop. So we'll set a current like we did in our other example, and we'll set that to head to start. And then we'll start our while loop. So we'll do while list1 and list2 while we have at least one item in both of our linked lists. And then in here, this is very similar to how we did it above. We're just going to we're going to check if list1.value is less than list2.value. And if it is, we're going to set that to current.next because it's the next one in line of sorted values. And then we're going to move list1 up to the next item in its list so that we are ready to check the next value. If it's not bigger, then we know list2 is either the same or bigger, or sorry, is the same or smaller. So if list1 is not smaller, we know that list2 is either the same value or smaller, and so we can set it to current.next. And then we'll move list2 up. And then once we've done those checks, we also want to make current equals the next value, so it's ready for the next time we go through the list. And we'll just repeat this until either list1 or list2 run out of values. Now what's nice is if list1 or list2 runs out of values, we know that whatever is left in list1 or list2 can just be added to the end of our current variable here. So we'll just check one final check if list1 exists, like if there's anything left in list1, current.next equals whatever's left in list1. If list2 exists, else if list2 exists, so if there's anything less than list2, current.next equals list2. And then we just return head because we saved it up here so that it was ready from the start, whatever the starting linked list variable is. Let's run it. Let's see if it works. And what we also can do, which is pretty helpful, is check the other cases that we planned for. So what if they're both empty? That passes. What if one of them has something in it? That passes. And what if they're all duplicates, which we already kind of tested in the original. There was a couple duplicates. This should just be all ones. That passes. Great, and we can submit this. There we go. Not bad on performance at all, especially for JavaScript. And we're ready for our next ones. Here's a couple more that we can do. Hope you enjoyed this. Hope you learned something on it. I know this one's a little more confusing. This is why I say Leetcode easy is not easy, because look at all the different things going on. You have to know what linked lists are. You have to know some of the, in this case, you have to know how how list nodes kind of work in this dot value and this dot next. You have to understand sorting and how not to copy an array over, so you have to understand a little bit about memory. But hopefully the algorithm was helpful and you learned a little bit about linked lists if you're not as familiar with that. And hope you join me for the next one. And thanks for joining me.